All right. Welcome back, my people. Hey, if you're not subscribed, please subscribe. Throw a like on the board. Let me know how everything's going out there. There's a free PDF in English y Espanol in the description. Feel free to download it, perform the problems, come on back, see how you did. All right, let's take a look at this. It looks like we have a word problem. Mario Kart Wii, one of the best games ever. Joshua and Frank are each trying to save money to buy a Mario Kart Wii game that costs $49. Okay, so that's the cost of the game. Joshua currently has $4 and saves $5 per week. All right, good job, Joshua. Frank has $16, but only saves $3 per week. Okay, that sounds good. That sounds good. Label and define the input variable. Okay, the input variable is X, and that represents time in weeks. The output variable is going to be J of X for Joshua and F of X, and that represents money saved. So the input is time in weeks, the output is money saved. I don't know, yeah. Okay. Write the equation that represents Joshua's savings. Okay, I'm going to call that J of X equals, notice Joshua currently has $4, that's the initial amount, and that's the rate of change, so $5 per week plus the initial amount of 4. The minimum and maximum input values. The minimum input values is 0 weeks. The maximum is how long it takes Joshua to save $49. So we want to know how many weeks will it take for the output to be 49, because that's the total needed to buy the game. Subtract 4 from both sides. Let's solve this equation for X. That gives me 45 equals 5X. Divide by that 5, solve that equation, and 9 equals X. So it looks like 9 weeks is how long it's going to take Joshua to earn the money he needs to buy the Mario Kart Wii. Identify the minimum and maximum of the output. Okay, well the minimum, and notice how we're talking about Joshua, right? We're talking about Joshua. The minimum amount that is the output is money, is $4. Well, the maximum is how much you need to buy the game. It's $49. All right, that's not bad. Let's write an equation for Frank. Frank is F of X equals, Frank has $16 and saves $3 per week. Input value, well, the minimum input is 0 weeks. The maximum is how long it takes for Frank to save $49. So I'm going to go here. I needed this space for something else, but I'm going to go ahead and use it. I want my output to be 49. Subtract 16, and you get 33 equals 3x. Divide by 3, and you get 11 equals x. That means it's going to take Frank 11 weeks to save $49. All right, the minimum is the minimum amount of money Frank has. That's $16. The maximum is how much Frank needs to buy the game. That's $49. Now let's find out how long it took them to have the same amount of money and what that amount was. So I'm going to go ahead and take Joshua and the function that changes his input to the output and set it equal to Frank. Okay, let's subtract 3x from both sides. Let's solve this equation for x. That gives me 2x plus 4 equals 16. Now I'm going to subtract 4, 2x equals 12. Divide by the dose, and x equals 6. Okay, so that's the input value, 6. To find the output, I can go here or here. I'll go to this one, and I'm going to input that 6. And that's 34. So that represents the time, number of weeks. That represents the money. So after 6 weeks, both Frank and Joshua will have $34 saved. All right, and that's the only time when they have exactly the same amount. All right, 634. Let's keep going. Okay, let's graph this thing. Let's graph it. To graph it, I'm going to go to Joshua. I'm going to find the minimum and maximum point. Remember, at time 0, Joshua had $4. And at 9 weeks, I believe it was. Yep, 9 weeks, Josh had $49. Our friend, Frank, started out with 16, and it took Frank 11 weeks to get $49. So here's time in weeks. I'm going to do increments of just 1. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that'll work out nicely. 9 and 11. And then we're going to go to 49. So this is money. Do increments of 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Joshua 04 is right there. And 949 is right there. Is this continuous or non-continuous? Yes, that's correct. It's non-continuous because they just put money in once a week. So every week they're putting money in. They're not continuously putting money in. So I'm going to show that it's non-continuous by giving a dashed line. All right, now let's talk about Frankie. Frankie started out with $16. Woo! But didn't quite save as much, so it took Frank 11 weeks to get to 49. Again, this is non-continuous because Frank just puts money in once every week. Okay, right about there, yeah. Okay. And we're going to go here. Boom, boom, boom. Boom, boom. Boom, 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 boom. There's Frank. Notice they intersect right there. That point of intersection, oh my gosh, it's so close, it's wonderful. 6,34. And if you notice, that is exactly the answer we got on the front, right? Those should match. They represent the same solution, it's just a different way of getting it. Equal values method, graphing method. But the solution is still the solution, no matter what method you choose. How many weeks will it take for Joshua and Frank to have the same amount of money? Well, that's the input value, so that's 6 weeks. And how much will they both have? That's the output value. So they'll both have $34. All right, let's keep going. How much will Joshua have after 6 weeks? Hold on. $34. We just figured that out. Is that a trick question? All right, how many weeks will it take Frank to save $31? So I'm going to go to Frank's equation. This is Frank's equation. And I'm going to let my output be 31 and solve it for my input x. Subtract 16. We have 15 equals 3x. And then you're going to divide both sides by 3. Boom, boom. And you get x equals 5. So it'll take Frank 5 weeks to earn $31. If Joshua chooses not to buy Mario Kart and says for a bicycle that costs $109 instead, how many weeks will it take Joshua to have enough money to buy the bike? Okay, so let's go to Joshua's function. J of x equals 5x plus 4. And we want to know how many weeks x will it take to earn $109. Subtract that 4 from both sides. That's 105 equals 5x. Divide by 5. Divide by 5. And you get 21 equals x. So it looks like 21 weeks. Woo! And that's done. Good old Frank and Joshua. They're good boys. They get their homework done. They work hard. They talk nice to their parents. They exercise. This is what we should all strive to be. All right, stay strong, Josh and Frank. Stay strong. Okay, see ya. Bye.